So we're going to have a look at some university calculus differential equations. So these are going to be ordinary differential equations. Now we're going to start with some nice easy ones. These are first or second year. These ones, if they were second year, they'd be right at the start, but these could be first or second year university. We're going to start with separable first orders. So we're going to have a look at some examples of separable first orders. So the question that we're going to do to begin with will be dy dx is equal to x times y squared. So for our ordinary differential equation, this is a first order differential equation because it just has a first derivative in it. We're going to separate this. We're going to move all of the x terms to one side, all of the y terms to the other. We're going to have the dx on the side with all the x terms and the dy on the side with all the y terms. We're going to treat dy dx as a fraction. So let me pick a nice color. So we have dy dx equals x times y squared. Well, given that the dy is in the numerator over here, all of the y terms have to go to that side. So we're going to multiply both sides by dx. It's going to cancel the dx over here. And we're going to divide both sides by y squared. Let's divide both by y squared. This gives us 1 over y squared dy is equal to x dx. Now that we have the equation in this form, we are going to integrate both sides. So once you've got all the y's on one side followed by the dy, all of the x's on the other side followed by dx, you can just apply integrals to both of them and integrate both sides. So we have the integral of y to the minus 2 dy is equal to the integral of x dx. Well, the integral of x is the easier one, so this will become x squared on 2 plus some constant of integration, which we'll call c. We have a y to the minus 2 here, so this, here for the x we increased the power by 1 when we did the integration. We're going to do that here as well. So this will be y to the minus 1, and this will have to be negative. So negative y to the minus 1, if you differentiate that, you'll pull the minus 1 down the front, cancelling the minus 1 will give you minus 2. And this will be some plus some other constant of integration, which we'll call d. Now at this point, the two constants we can put together. So we can minus d from both sides. We then have c minus d on the right. We'll just call that a new constant of integration that we'll call e. So we have minus 1 on y is equal to x squared on 2 plus constant of integration e. Now we want to solve this for y, because we're trying to find a solution in terms of y equals. So we'll multiply both sides by y. This will give us minus 1 is equal to y times x squared on 2 plus e. We'll divide both sides by x squared on 2 plus e. This gives us y is minus 1 over x squared on 2 plus e. Now for the purpose of a first order equation of this form, we could just leave it like this, and I actually will be leaving it in this form. So this is one iteration of a possible solution. It's not the only possible solution. So it's not the only way to write the possible solution, but it is one way to write the solution. This gives us y as a function of x, and we were able to find this by using separation of variables. So we moved all the x's to one side, all the y's to the other side, the dx to the side with the x's, the dy to the side with the y's, integrated both, solved for y. That was our process. Now a lot of people will tell you at this point you're finished, and you're not. we now have to check that this actually works. So we have to take this function, we have to differentiate it, we have to plug it back in to the first order, and this will let us confirm that this actually is a solution. Because if you take a derivative of this, plug it in, and it doesn't work, then you have problems. You have a wrong answer, right? So here we have y equals -1 over x squared on 2 plus e. So I'll do this as a quotient rule to find the derivative. This is u, this is v. So we have u is -1, u prime is 0, v is x squared on 2 plus e, and v prime is going to be just x. So now our quotient rule tells us that dy dx is going to be u prime v minus uv prime. So u prime v is 0, uv prime is minus x, this is minus x, divided by v squared, which is x squared on 2 plus e squared. So this is our derivative. And this is in fact equal to this is a plus, sorry, this is u prime times v minus u times v prime, so minus 1 times x gives us a plus x in the numerator. This is equal to x times -1 on x squared over 2 plus e all squared. And this is the form of the original equation, the one in yellow up the top. So this is dy dx equals, if we do it over here, is equal to x times y squared. This checks out. So we calculated the solution over on the right, and then we were able to confirm the solution over on the left by differentiating the function and then confirming that the derivative of the function that we just found is consistent with the first order differential equation. So this is a pretty basic equation. It's very simple integrations. It's a very, very short differential equation. It only takes a couple of minutes. But this is one way that you can do first order separable differential equations.